TV built in. Yeah, it's a beautiful ball. Okay, so I'll make a folder for my sprites. I'll make a folder for my physics materials. So 3 folders I just made. We're going to need script, sprites, and physics materials.
Sorry, stupid question. What's the command to create a folder?
Oh, I don't know.
Not sure.
I just right click. I think Control N makes a new game object. I don't know the shortcut to new folder in Unity. It's Control N in Windows.
Did you try to insert this assets with balls into the scene?
I haven't put anything in the scene, no.
I tried, but nothing appears.
Mm. It does appear though. It's just very, 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 very small.
It's very small.
Yes. So we're going to change our import settings for our sprites so that they match our grid. But it'll look like there's nothing there, but it's very, 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 very tiny. But I'm not quite there yet. I've got my 3 folders. I'm going to move my physics materials into my physics material folder. And then the new images, I'll do that first. 1, 2, I've got 4 of them into the physics material folder. My sprites are the things I just imported, the dotted line, the ball, the racket, and the 2 walls. I'll put those into my sprites folder. Mm, 5. Okay. Camera settings, we need a size of 40, and then we're just going to change your background to whatever color you want. Black is the default, but whatever you want. Just something that the white things will contrast well against them. Let's select the camera. We're going to change our size here. I actually think 40 might be too big. Let's go 30. 30. Relative though. Zoom out and it won't be so big. Still on the camera, I want to change my background color. So down in environment, it's set to skybox. I'm going to change that to solid color. And you can see that's the color we have in our background here. If I go to game, see that's the color. I can change that to whatever I want. But since we have white objects that are going in front, we need to be a bit dark. Black, you can go. I'm going to go for this interesting purpley red. Wine, yes. So a nice dark color for your environment. And again, that's on the camera. If you just go down beyond rendering, you'll see environment. By default, it's on skybox. You want to change that to solid color. So we have some import settings. They're the same import settings for all of the sprites that we have. Pixels per unit is one, and that basically means the amount of pixels that are in there will be mapped to the grid space in Unity. So a grid unit in Unity. And the other thing is we want to change the filter mode from anti-alias to point no filter. So if I don't change any of these settings and I just grab, let's say, the dotted line, I'll start with the dotted line. If I just drag that straight into my scene, it looks like it's not there. But that's because it's such a small, it's actually dotted line is what I've selected first. I've dragged it in and it's like it's not there. It's because the pixel value is so small that we cannot see it, which is why we want to remap this to be per unit size. So it is there. If I select it, if I double click, you can zoom right in. There it is. Tiny, tiny, tiny. If I go up to or I select in my assets the dotted line. I go to pixels per unit. Right now it's 100 pixels per unit, which is why it's so small. There's 100 pixels in 1 unit. Change that to 1. And then click apply right down here. So pixels per unit, 1. Click apply. Hey, there it is. You see it's kind of smoothing it over, anti-aliasing. That is because of our filter mode. Again, it's in the tutorial. Change that to point no filter. And click apply. And you see it switch from being blurry to being a clear pixel image. I selected it, yeah. 2D. So, let's add the rest of our objects. Yeah, there's 2 things you need to change on each one. Okay, so next I'm going to import my wall horizontal and wall vertical. And Again, you can't see them because I haven't changed their import settings. I'm going to select both wall horizontal and wall vertical at the same time. So they're both selected, and I have them both imported into my hierarchy. You just can't see them because, again, they're so small. And then the two things I'm going to change, pixels per unit, change that to 1. And filter mode. So you can make this change for all 5 sprites in the game. Pixels per unit 1, filter mode, point no filter. But it will make a difference because it's very, very small. And then if you have to scale it up, then you've got different scales. Whereas if these all have the same scale, they'll just fit together. Fair point. But isn't it good to know these things? So once I click apply, both of these should jump into view because the pixels per unit has changed. There we go. I'll add my other 2 objects next. I'm doing them one at a time. So my racket and my ball. And again, can't see them because I haven't applied the point no filter and the pixels per unit. So again, I'll select my ball and my racket. And then both of these should just pop into existence. They are right here. They're in the world. They just need this change to be made. 1, point no filter. Click apply. Next, we need to look at what needs a collider and what doesn't need a collider. So the dotted line does not need a collider. We need the ball to be able to pass over that. That's just a dividing line in the center of the course. Everything else does need a collider. So let's select everything except the dotted line. But let's add the collider first and then duplicate. Otherwise, we have to do everything twice. And we're going to need 4 walls as well. We need more than 2. But let's be smart. Come on, guys, let's try it. Yeah, so all of these are selected at the same time, except for dotted line. I'm going to add box collider 2D because they're all boxes. Add component, and I'm just going to search for it this time. Box collider 2D. The racket and the ball are going to be in motion, which means we are going to use rigid bodies for them. So I'm going to select both the ball and the racket. rigid body 2D to both of these. Oh yes, I've added a box collider to all of everything except the dotted line. Well, we're going to use rigid body. No, we're going to make the ball move using rigid body physics, and we're going to make the racket move by using forces to move it up and down. So it will also have a rigid body. But I know what you're saying. We could use a transform thing. But the ball, yeah, we do need physics to calculate like rebounds off the walls and everything. So again, add component. I'm going to search rigid body 2D. At this point, save your scene because we've done quite good stuff here. In my scenes folder, on one. Oh, I'll call it point. Okay, next we'll just construct our Pong layout. We have our pieces in place. We just need to get our walls in place, put our dotted line in the middle. The little camera icon is telling me where the center is. And don't forget the V command for snapping. If you hold V as you're in move mode, you can snap the corners. Give you a nice lineup. I'm just going to duplicate, Control D. V, snap. Yeah, if you're in move mode and you hold V, it'll snap to the vector points. And yes, we're going to need 2 rackets. So let's duplicate our racket. But now it has a collider and rigid body. It saves a bit of time. You hold V and then move. Like click and drag and it'll snap. Did you sign in? Just check that your colliders are working. Press play. See your racket and your ball fall to the ground.
My rackets are kind of like not working, but falling down when they hit the ground. Yours they stay solid.
Are they turned or something?
Yeah,
Like
like this.
Yeah.
It's supposed to happen. It's not supposed to happen.
like that? That's what's happening?
Yeah.
Oh yeah.
Oh.
Yeah, that's fine. The physics are just working. I mean, you can just you can always reset back to default. Just look at your transform rotation. If you want it to be perfectly flat, just zero it all out. Okay, so we want our ball to be bouncy as well, so let's add our physics material to it. Bounce full.
This is something that was happening even in my project.
Hmm.
I needed to go faster.
Hmm.
The object is go inside of the other one.
Yeah.
I need to put math, but even though sometimes it wasn't working.
Mm. It's your collision detection, maybe. If it had a sharper collision detection, it wouldn't be able to pass through.
Because even here, if you just pass through the ball, you can just go through the ball. So.
Yeah. Well, on your rigid body settings, there is a different collision detection modes. Discrete is running every frame, but it has continuous that is slightly more accurate. So if you have the things that are moving fast with continuous, there's less of a chance it'll pass through. So we'll probably find that with Pong, it'll pass through the walls. Anyway. Whoa, whoa, whoa. Okay, so a little bit of renaming to go on here. Just going to change the names of my walls so I know which is the top and which is the bottom. Wall on the top, I will call wall top. Wall on the left, I will call wall left. Wall on the bottom, I will call wall bottom. Wall on the right, I will call wall right. Racket on the left, racket left. Oof. Racket on the right, I will rename Michael the racket. No, racket right. center. Yeah.
Maar doet dat dan initiale blur?
Ah, yes. In the import settings, you just need to change to point no filter. So you select the asset. I just want to leave that open.
Aí eu programou de novo ali de código, né? Tu tá animando. Ah, bem pra lá. É, mas mudou, né? Aí, qual que é o rolê? Tipo assim, eu posso falar assim, não, e a parte que eu tava falando, vai ter os caras que falam,
Yes, so the change that we made,
aí, tipo, vou migrar, né? E aí eu tenho que chamar duas caixas, uma parada assim.
first we changed the disk experience to one, that's going to make things a lot
Duas
bigger.
caixas, é normal, quase assim.
And then
Só que, mano, o
the
cara
thing that made it blurry is this filter mode here, by linear.
Aí
We over it, we were
eu
going
falei,
to
meu
the same
coração.
one.
Eu falei, mano, é mais caro pagar gasolina no teu carro do que pagar caro pra caralho no maluco, né? Aí
They're
eu
way bigger.
Quando
But
eu
if you
tenho
want to
de 2020, hoje em dia, você me fala, tipo assim, mas não dá. E fica aqui, pode vir. Quanto eu trabalho? Não, isso não importa, né? Porque se você falar, é só. Mas o desafio é que nem fazer um bolo, né, mano? Vou meter a mão no bolo. É o quê? Quarta? Beleza, eu vou pedir lá então, como no trabalho. A gente não tem nada, show. Pode ser entre meio-dia e 1 hora. Pode ser. Boa. Quarta-feira,
Jump down
28,
to
né?
reposition things.
Right, so a bit of scripting to get our rackets moving next. So first we'll just select a racket. We're going to create a script. Actually, I'm going to do it a different way. I'm going to make the script in my scripts folder first. Right click, create mono behavior script. And I'll name it move racket. have a rigid body on the racket. We're going to use physics to control this one. As I said last semester, when we're working with physics, we always want to use fixed update because it's in line with the physics engine. So I'm just going to modify this update to say fixed update, capital F. Then I can remove the start method because I won't need it. Or if I do, I can bring it back. No, thank you. I'm going to need a speed value to control how fast my racket is going. I'll give it a default of, I don't know, 3.5. Oh, let's go 10. 10F. I'll make it public as well. You can see in the tutorial we access our input manager for vertical. That's going to come in handy in a moment. But basically vertical is referring to the buttons in the input manager that are there already. It's not. It doesn't mean up and down. It's literally just a name inside of Unity. And then we're going to access our component, our rigid body 2D, the velocity, which is time, distance plus time, velocity. So inside of our project settings, you can see here's horizontal and here is vertical. So that's what we're calling on when we call on, in quotes, the string vertical. We're actually calling on up and down arrows and W and S arrows. So up positive, down negative, alternate W and S, WASD. So what it does is it stores that positive and negative, the W and S, the up and down arrows, as a float, V. And it uses getAxis raw. There's also getAxis. So accessing the input manager, getting getAxis raw, and applying vertical to it. Float, V for vertical. Input.getAxis raw. And then we name the axis that's in the input manager. Vertical. And then we want to access the rigid body component. So get component. Holy crap, did I get autocomplete? Oh, thank you, Unity 6.3. Get component, rigid body 2D, open and close parentheses, dot velocity. I was so happy for autocomplete. That ruined me. Unless it's changed to angular velocity? I don't think so. No, yeah. There we go. Okay. New vector 2. So last semester we were working with vector 3s. Hmm? That's why it's not letting me put it in. So linear velocity. So with vector 3, we have x, y, and then z represented as the three numbers. We were using this for checkpoints, for positioning stuff. Vector 2, we don't have the z, the forward, it's just x and y. And we want to move our rackets up and down vertically, so we want to affect the y-axis. Which is why we're going to put the v in the second value here, because we're accessing that and applying to the vertical, the y-axis. Yes. Yes. Yeah. The forward direction, basically. Mm. Yeah, unless we're doing something that needs to come forward somehow. So maybe detection stuff. Yeah. Or if you're blending 3D and 2D and you want to have maybe something rotating in 3D, you might need to access the Z of it. Or mouse clicks and stuff, you want to detect where on the Z, like you're looking forward, you're shooting rays from the screen in to detect, something like that. There is cases when you'll need a vector 3. And then with that script created, we should be able to test this. I'm going to drag my script onto my racket. So move racket script is there. Speed is 10. My rackets are falling. Oh, here we go. All right, the classic. I'm going to have to reset Unity because of this. So, when you press play, do you also get this message? You were trying to read input using the input class, but you have switched active input handling to input system package. You might remember from last semester, we're putting our character controller in. Okay. Well, it could just be that the mass and the gravity is up there, so we're not meant to use gravity. But anyway, I'm going to save And then I'm going to change in my project settings, is it player? Yeah. So in your project settings, if you're getting this error, you need to basically use both the input manager and the system package. The new system package is still buggy. All kinds of problems with it. I'm going to change that to say both, and it's going to say you're going to need to restart for this change to take effect. So yeah, let me go through it one more time. So in edit and project settings, so edit and go down to project settings, and then you're looking for player and input. But you can just search from the top for input and it'll find it. Edit, project settings, player, and I can search for input. And see there it is, active input handling. And I'm going to change that to both, and it's going to reset Unity. Phew. What's happening? The mass of the ball should be very small. 0.0003 on the rigid body mass component. Or 1, sorry. You also want to freeze rotation on the ball, which in the old things had fixed handle, but in ours it's constraints, again in the rigid body settings. So freeze rotation of the ball. Yep. Hey, I'm back in. Input handling, both. And now if I press play, let's see if I can actually affect this bracket on the left. I can move it up. Okay. Quick check on racket left. You do have a rigid body.
Yes.
Okay. You do have the move racket script.
No.
You have the script on? Okay. Are there any error messages about the script? No? Okay.
It's working now, yeah. Great.
Okay. But only for you.
FISED. Okay.
Unity didn't seem to have a problem with it because it was treating it as a new method. It was like, oh, he's made a brand new method for us. So we've created a float V for making it move up and down. This isn't in the tutorial, but in the input manager, you'll notice you also have an axis set up for horizontal. And that takes in the left and right arrow keys, left and right, as well as A and D. If we wanted to move this thing forward, it's very easy to look at this and see how you could do it. Basically, we make another float, access the input manager. Float H, horizontal, we'll call it. And we'll input. Why don't we just copy the whole damn thing? Oh, no, there we go. Horizontal. What your problem is now. And now we're adding new vector 2. X is the horizontal. We can just apply the H value to it. Now it's reloading that script. Left and right. I have control. I know. But we could set a range limit. Oh, and this thing you're moving up and down, this could be your Hades character. You're just moving something around the screen. Anyway, yes, you can see why we should probably freeze our rotation as well. So I'm going to do that for my racket left. Also, we don't want to use gravity because our rackets are just falling down. So I'm going to turn the gravity scale. So this is racket left I have selected. I'm going to say gravity scale 0. Under constraints, I'm going to freeze rotation. Racket right, I'll do the same thing. Freeze rotation. Gravity scale 0. I'm also going to add the script component to this as well. Yep. Well, we'll fix that as well. Don't worry. Don't worry. But yes, that means that right now both of them are moving at the same time. And they can both move left and right. Yeah. But the dotted line. Yeah, it's not meant to. It's meant to be like chalk on the ground. linear velocity. That's the update from the tutorial.
Yeah, my racket's not hitting the ball.
Okay. Okay. Do they both have colliders? Does the ball have a collider? The racket have a collider? All right. I'll take a look. Okay. Little script change we're going to make though. First, to make so we can have two-player, need to make a public string value called axis. This is so we can use the same script for player 1 and player 2. I'm going to replace where it says get axis raw vertical. I'm going to replace that with the word axis, not in quotes because it's a variable. I'm going to give this a default value, the string value axis of vertical. Save the script. So yeah, this is right here. Very important that not in quotes or anything. It is reading the variable name axis. And back in Unity, you'll see on racket left, it now tells us what axis we're using, which means what keys we're using, what buttons we're using in the input manager. On racket left, I'll leave it at vertical. Racket right, it's also on vertical, which means they're still using the same keys. Let's go back to our input manager, edit project settings. And you see I've got 30 different axes that are being used. I'm going to change that to 31, which means I'll add a new one onto the end. So whatever number you have, you might have 19, you might have 30. 31. Again, I'm in the input manager. And then right at the very bottom, it will be where the new one is created. I have another debug horizontal. I'm just going to rename this vertical 2. And I will use I and K, O and K maybe. Positive button O, negative button K.
Because if you set the arrows, it will affect the other one. So I need to be one with arrows and the other one without.
Okay. So the right, this is racket right, so this should be arrows. Right, so All right, you've made it more difficult, but I don't mind. Let's go back to vertical, which is using arrows down and up. And we'll just say, yeah, get rid of them. So no positive, negative for them. And then down in vertical 2, I'll keep K and O as alts. Alt negative will be K, alt positive O. And it's just down and up. You've got it. Teach this class. So yeah, once you have vertical 2 set up, fingers crossed, you should be able to select either racket, racket right, and change its axis to vertical 2. And because we named it that in the input manager, it should register our new key commands. So I can press W, A, and S to go up and down, and then up and down on arrows to move the other one. We have independent 2 players. Please tell me if it's not working. You can take a look.
Could it be the screen? Ah, yeah. Oh, we need to freeze rotation on the ball as well. Clearly. What makes something pass through a leash? Because it wouldn't bounce on the ground if it was a trigger. Huh. I don't see any blocks still there. And also its size is really small. How about we reset 2 and 4? Ah, ha, ha, ha. I don't know. Maybe did you create this when it was very, very small?
Yeah, I think so.
And then we did the pixels preview reset. Aha!
Oh, that's it then.
Yeah, so we just set the all. There you go.
Oh, that's
That will work. I don't even see. I don't even see. I'm so confident.
Save. Control S. Okay, so the ball. The rigid body of the ball, we need to freeze rotation and lower the mass. 0.0001. Very small.
Coloca no capo.
Okay. Let's make a new script. New monobehavior script called ball. First up, a speed value. Yes, it's autocomplete. Public float. Speed equals 30f. And I'm also going to make a private variable, rigid body 2D, called ORB. In start, I'm going to assign this, oh, it's already doing it for me. ORB equals get component rigid body 2D. This will just save us having to write out this get component line again and again. ORB dot add force to give our ball a starting force. Zero on, oh wait, it's the X first. No, that's not add force. ORB dot linear velocity. Might as well keep it the same way. Dot right times speed. Yeah. I mean, you could add a random thing as well to flip either one way or the other. But in this version of the game, yeah, it's always going to start moving to the right. Yeah. Yeah, like literally the line before could be random 0 to 2, and then if you'd have a little if statement. If it's 1, go left. You can test in Unity, see that it's going to move. Nope. Thank you. I did not add the script to it. So let me just drag the ball script onto the ball. It's the first day, guys, you know. We're all a bit rusty.
Why is it just going so yeah, like this, like a shot. It works like this.
Oh, it's gone. So, things I forgot. I forgot to take the gravity scale off my ball. Turn that to 0. And also collision detection. I'm going to increase that to continuous to try and stop it from disappearing outside of the frame. So 2 things on the ball that I changed. Stops. Does does your ball have physics material? Okay. So it just stops and it hits, doesn't rebound. Okay. On your physics material, what do we have? This is what my physics material is. Bounciness 1, friction 0. Yep. Do you have vector 2 right in your ball script? Do you have that in update, by any chance? Damn.
Read rotation of the ball.
Yeah. Stops it, doesn't rebound. Doesn't fall. Oh yeah, what's the max on the ball? 0.001 maybe? 0.001. Yeah. And yeah, see your regular bounce. And that's on the collider of the ball, is it?
Yes.
Plus 1 degree. Okay, so heat scale, step 1. Go down. That one.
Okay, friction.
Okay, press play. Adjust the mass to like per inch. Right.
Okay, the next important thing to calculate is our racket position, our ball position, and the collision angle. Mathematics, yes. Zero, zero, right in the center. So x being the horizontal, 0 and 1 is the top of the racket, 0 and -1 is the bottom of the racket. So we need to make a little hit factor method here. It's going to take the position of the ball, so we know where the ball is on the racket. It's going to take the position of the racket in space. We're going to subtract those two from each other. And then whatever the racket height is, it's going to divide by those. So if we make our racket longer or smaller, it's not going to matter. It's just going to say where it is versus the center of the racket to the top or the bottom, plus or minus values. So back in our ball script, float, hit factor. Vector 2. Oops. Ball position. 2. Racket position. So X and Y positions. And then the height of the racket is a value, so it'll be a float value. Racket height. Open and close our curly brackets. And then, yeah, it's giving me an error because we're not returning a value. We will return a value. And again, we want to return the value of the ball position on the y-axis, the racket position on the y-axis, the vertical, divided by the racket height. Yep. Next, we need an on-collision enter function to detect when the point of collision happens. So we did on-trigger enter last semester, and a bit of on-collision for the ground check, checking when we touch the ground. I'm going to use it here to check when the ball and the racket collide. Collision, collide. So yeah, probably, no, I might. Anyway, void on collision enter 2D. Collision, collision. I'll change that to call as the reference. Hit factor, direction, yeah. If game object dot name. So col is the reference name there, whatever you named it. If you left it as collision, as it was by default, then it needs to say collision there because that's the reference to it. I generally keep it something short, like col or C, so I save myself some typing. So we want to call our hit factor and apply it to our actual things because this just created the method that hasn't been applied to anything. So for ball position, this script is on the ball. So the ball's position is the transform position of this object, this.transform position. The racket position is next. We need the ball position, the racket position. Racket position would be the second one. And that would be the position of the thing we collided with. So call dot transform dot position. And then this is one I always forget because it's long. We need the collider bound size y of the object we've hit. Collider bound size y. So again, col is the racket. We need the racket height, so it's col again. This is the object we've hit. Dot collider dot size dot bounds dot y. Bounds first. See, I always forget it. It's too long. Dot size dot y. Which you might feel is confusing, but it's the object we hit, we collided with, col. It's detecting its collider, and then the boundary of that collider on the y-axis. So size is to get the measurement. Yeah. Yeah, so, but it'll be the height of the racket the second the ball touches it. So if you, say, had a power-up where the racket got bigger, it would calculate that anyway and know how to react to it. Oh yeah, we have to store this as a float value, so we can apply it to the direction. I'm going to call it float y. Semicolon. So our new direction will be a normalized direction. This means it maps between 0 and 1. Again, it's our x and y value. The x value, because we're hitting the racket on the left and going to positive, will be 1. Just give it a solid 1. And then our new calculated hit factor, called y, will go on the y-axis. So what we're doing is telling the ball that it must go straight back horizontally, and then on the vertical, it's going to apply our hit factor on the up and down. Yes, except we're going to minus 1 on that, so yeah, ever so slightly different. And then linear velocity, because that's updated that. Or b dot linear velocity direction times speed. And it's the exact same for racket right. I can just copy it all except for one tiny detail. Copy and paste. The direction needs a minus. So the only difference between those two and simply because traveling left to right, the normal reading thing, that is a positive. So a +1 will send it going left to right. And you'll notice that even if it taps it like on the top of the racket, it's going to just unnaturally turn back around. But at this point, you can save and test. It should work. I will also save, go back. And it already looks like it is working. Yeah, it hits the top of the racket, it flies away in different angles and directions. Make absolutely sure though, and move my rackets out of the way. See, it hits the wall, just goes straight back and forth, back and forth. I catch it right in the center. Oh, it's still not quite in the center. And if I flop these values, I make this the -1 and this the +1, what do you think is going to happen? It's going to break the game. This -1, +1, which again, not great that you can just break a game with one thing like this, but It means that now when it hits the racket on the left, it's going to try and go back to the left even more. Oh, not quite. Did they save? Oh no, apparently not. Jeez. It doesn't mind. Cool. Maybe this is something that used to break the system. Anyway, I shouldn't try and break the game. Just bouncing. Anyway, 5 minutes to spare. I'm glad we got the foundational part of Pong done. Mm-hmm.